In question 8, a progression has first term a and the second term a squared upon a plus 2, where a is a positive constant. In part A, for the case where the progression is geometric and the sum to infinity is 264, we have to find the value of a. Now, the formula for sum to infinity is a upon 1 minus r. So the sum to infinity is given as 264, which is equals to a upon 1 minus r. Now, to find a, we need to make a substitution in place of r. Now, r is basically the common ratio, which is found by dividing two consecutive terms. So we can divide the second term with the first term. So the second term over here is a squared divided by a plus 2. And we'll divide it by the first term, which is a. We can write it as a squared upon a plus 2 will multiply by 1 upon a. A and a will cancel out. So r will be equals to a upon a plus 2. Now substituting in place of r, a upon a plus 2, we'll get a upon 1 minus a upon a plus 2 is equals to 264. Now first taking the LCM in the denominator, we'll get a upon, so 1 will multiply by a plus 2, that will become a plus 2 minus a upon a plus 2 is equals to 264. So a and a will cancel out. This a plus 2 will multiply with the a in the numerator. So that will become a into a plus 2. And we'll multiply the 2 by 264. So multiplying 2 by 264, that will be equals to 528. So this will become a squared plus 2a minus 528 equals to 0. Now we can use our calculators to solve the quadratic equation, or we can do middle term breaking, so that the two factors will be 24 and minus 22, as 24 times 2 is 528. So we'll do 24a minus 22a minus 528 equals to 0. Taking a common, this will become a plus 24, and over here taking 22 common, this will become a plus 24 equals to 0. Simplifying, we'll get a minus 22 and a plus 24 equals to 0. As a has to be a positive constant, and the two values of a that we are getting are a is equals to 22 and a equals to minus 24. So the value of a that we'll choose is a equals to positive 22, as a is a positive constant. In part B, it says for the case where the progression is arithmetic and a equals to 6, we have to determine the least value of n required for the sum of the first n terms to be less than minus 480. Now, the sum formula for an arithmetic progression is n upon 2 into 2a plus n minus 1 into d. Now, the first term was a and the second term was, so it was given as a squared upon a plus 2. So as a is equals to 6, so a will be 6, and this will become 36 upon 6 plus 2, which is 8. So the first term will be 6, and the second term will be 36 upon 8 is 4.5. Now, as we have the first term and the second term, which is 4.5, we can find the common difference. So the common difference will be 4.5 minus 6, which is equals to 1 minus 1.5. Now it says that the sum to infinity must be less than minus 480. So we know that the sum must be less than minus 480. So substituting in place of sum of n terms, we'll substitute the formula, which is n upon 2 into 2a. So that will become 2 times a will become a 12 plus n minus 1 into minus 1.5. And that will be less than minus 480. Multiplying 2 on the other side, we'll get n into, so this will become 12 minus 1.5 times n will become a minus 1.5n. So this will be minus 1.5n, and minus 1.5 into minus 1 will become a plus 1.5, and minus 480 will multiply by 2. So minus 480 times 2 is equals to minus 960. Opening up the bracket, we'll get, so 12n minus 1.5n squared, and this will become a plus 1.5n as less than minus 960. Now 12n plus 1.5n will become a 13.5n. So taking 1 point as the n squared term is negative, so we can take it all on the other side and write it as 1.5n squared. We'll make it a positive. 12n plus 1.5n is 13.5n. So that will become a minus 13.5n minus 960 will be greater than 0. Now to solve this, we can first multiply the equation by 2 to get rid of the decimals. So this will become 3n squared minus 27n minus 960, and that will be greater than 0. Once we have this, we can apply the quadratic formula to find the value of n, or we can first simplify it by dividing this value, the whole term, by 3. So as we multiplied this by 2, so 960 also had to multiply by 2. So this would have become 960 into 2, which would have been minus 1920. So in place of 960, we had to write 1920. And I'll have to use the correct color. So that will be minus 1920. Now dividing the whole term by 3, so that will become 9 squared minus 9n, and minus 1920 divided by 3 will be equals to minus 640, greater than 0. Now applying the quadratic formula for n, so n will be equals to minus b. So that will become a minus 9 plus minus b squared. So b is minus 9. So that will be minus 9 whole squared minus 4 into 1 into minus 640 divided by 2 into 1, as the squared term coefficient is 1. So this will become plus 9 plus minus. So this will become 81 plus the square root of 4 into 640. So this will be 4 into 640, which is equals to 2641. So this will be the square root of 2641 divided by 2. So this will become 9 plus minus the square root of 2641 is 51.3. So 9 plus minus 51.3 divided by 2. And as n has to be a positive number, so the only value of n will be n is equals to 9 plus 51.3 divided by 2. So 51.3 plus 9 divided by 2, that is equals to 30.19. Now, as it said, we have to find the least value of n required for the sum of n terms to be less than minus 480. So as n is 30.19, we have to make the sum less than minus 480. So we'll use the value after 30.19. So the final answer for n will be n equals to 31. For n equals to 31, the sum will go below minus 480.